Hello friends, welcome to our channel. In this video, we are going to look at today's daily challenge problem 1765, map of highest peak. Actually, if you read through the problem statement, it's actually a multi-source breadth first search or traversal solution. First, let's quickly look at the problem statement. So here we have a matrix called isWater. If the cell has a value 0, it means it's a land cell. If it's 1, it's a water cell. So notice this convention, right? 1 corresponds to water, and 0 corresponds to land. So we must assign each cell a height in a way that follows these rules. First, the height of each cell must be non-negative. In other words, at least 0, right? Should be greater than or equal to 0. And if a cell is a water cell, then its height must be 0, right? So any two adjacent cell must have an absolute height difference at most 1, right? In other words, the low and the high, the difference is less than or equal to 1. So they are either the same, or the low is 1 less than the high. So this defines adjacent, and it means four-directional adjacent, right? So we want to find an assignment of heights such that the maximum height in the matrix is maximized, right? So here we want to return the resulted height matrix. So here let's also look at the constraint. So here there at least one water cell, because this water cell will correspond to a height 0. So this is the very essential for this problem. Otherwise, if there were no water cells, then we can actually assign infinity to each of those, right? Because this problem is maximized, so we need actually in principle return infinity, right? That's the main problem statement. Here you see m and n are bounded above by 1000. In other words, m times n is less than or equal to 1 million. So this is the problem size, right? So with that said, let's look at the example 2. Example 1 is so easy, right? So for example 1, so the isWater matrix is given like this. It's 0, 0, 1, and 1, 0, 0, right? And 0, 0, 0. Notice that a value of 1 corresponds to a water, right? So actually we can initialize a result matrix like so star star or infinity infinity, right? Infinity infinity. Then first we start from the water cells. So here this position is the positions with 1s. So we assign them value 0s. Then we use this constraint. Adjacent cells must have an absolute height difference at most 1. Then we can assign the neighbors. So next layer, let's see. Next layer. So we find the neighbors of those, right? So let me copy this one. So this is next to 0, so we make it 1. So this is 1, right? So if we look at this 0, this 0, and here also we send 1. So here 1, and here 1. And then we go, this is the 1 layer. So then next layer. So we look at those next to 1s. So here, this 2, right? Here is a 1, or here also is 1. Similarly here. So we're going to send this one. Let me copy this one and change the values. So here must be 2, right? Because it cannot further large. For example, if 3, so the difference will be 2, right? So in other words, the maximum height is 2 for example 2. So if you look at this, the 1, 1, 0, 0, 1, 1, 1, 2, 2. That's the return. So with that said, actually, this procedure actually demonstrates the way we are going to do the coding. So now let's look at the specific coding. So actually, you can follow me when I do the typing. So as a routine, let me first get the number of rows and number of columns. So then I'm going to initialize a result. So here I'm going to do this float. I'm going to assign it to be very large, and then times, so we have n columns, then for a dummy index from range m. So this result will be an m by n matrix. This is what we want to return. Then I'm going to use a deck. Actually, what we are using for this deck is a queue behavior. So then we need to scan the whole matrix is water, so that we know the positions where the value is 1. That's the original water position, right? So basically for I in range m, for j in range n, right? So then if it's water, so at this position, so if its value is 1, right, then we are going to do append ij, right? So this actually gives the initial state of the queue. This is the sources, right? So now we can initialize a height variable. Originally it's 0, because for the first layer we are going to assign the values to be 0. So initially corresponding to water cells, right? And then we do radiate layer by layer. So we can do this well queue. Then first we get the length of the current queue state. So we need to do this number of pop operations. So basically for, let's use a dummy index for in this list, right? Then what we are going to do is we get the position sq pop left. So then if result ij, so in other words, we haven't visited ij before. So this is the float infinity, right? So here I'm using this matrix, also using this initialization to check if we have visited this position or not. So if this position hasn't visited yet, so what we're going to do? So notice that this check is very important. So let's see. If this not visited yet, we are going to set the current value to be height, right? And then we are going to check the neighbors. So for x, y in the potential for neighbors, x I minus 1 j, I plus 1 j, and I j minus 1, I j plus 1, right? So we need to check if xy is in bound. So if 0 less than or equal than x less than m, and 0 less than or equal to y less than n, right? And we need to check if this position hasn't been visited yet, so it should be float infinity, right? So if this is the case, so we are going to append this to the queue. Then we do next layer of assignment. So after this for loop, we are going to increment the height by 1, because the next layer, so we at most we can assign them to be incremented by 1, right? Due to this assumption. So any two adjacent cells must have an absolute height differences of at most 1. So this is the at most 1. So with that said, we just need to return the final state of the result matrix, or to the array, or to the list. So let's do a quick check. Yeah, it passes the two examples. Now let's look at the generic case. Let's see. So let's see if ij equals 1. Let's see. See what does this say. List index out of range. Let me check that. So ij for I in range m, for j in range n, right? Is water ij equals 1. So we do append for ij. Let me check. So here I guess I forgot is 0. So this is the number of rows, and we need to put a 0. This is very standard, but this is some typing issue. Now let's submit. Yeah, it passes all the cases. Actually, we can run this because there's two examples by chance. Is one is 2 by 2 and the second one is 3 by 3. So this m and n are the same, right? So now let's submit again just to verify that, right? Yeah, it passes all the cases. I guess that's basically about it for the current problem. If you are interested, you are welcome to explore our channels for other playlists. For example, the list for graph for doing all kinds of traversals, BFS based or DFS based. So with that said, that's it. Thank you.